Good afternoon, everyone. Just want to make sure first the audio is working good. Someone can just give me a thumbs up or something. Yeah, perfect. Good. Okay, today I'll be going over the mobile radio communication system project. My name is Rene Larocque. I'm a senior telecom engineer working for Nova Scotia Power. I've been doing this for over 20 years now as a telecom engineer. So it's a big project I'm going to go over. I'm going to try to go over the project team, focus on the system itself and the engineering side of the project. Okay, so let's get going here. Just one moment here. Just trying to get the slide to. Okay, we're good. Let's get going. Okay, so the mobile radio communication system, the project deployment started in 2017 and completion in 2019. So this was filed with the UARB for 6.3 million. The UARB is our regulatory body that approves all the big project spending for Nova Scotia Power. I'll go over the NSPI project team, the old mobile system, radio system overview, and the new system overview. We'll go over the vendor selected, new mobile radio technology, the infrastructure, engineering design, and mobile radio system benefits, completion in 2019. And of course, Hurricane Dorian, testing the system. So the NSPI project team was those were people that were engineering design and mobile radio system benefits. And of course, Hurricane Dorian, testing the system. So the NSPI project team was those were people that were mostly dedicated to the project. Myself, I was the engineering lead and project manager on it. So I was doing all the RF design, overseeing engineering, and also making sure the project is on time, on budget. Another key engineering member was Alex Hunt. I also did engineering design and implementation. Alex did a lot of the backbone, server installation, design, IP design in the background, make sure everything was set up so when we deploy it'll be a smooth deployment. He also did a lot of site drawing and design there. Vinny Takar, same thing, very similar role to Alex, did a lot of networking, server work, also a lot of site drawings and help whenever we needed him for troubleshooting things in the field. Karen Vernon, she was our project coordinator. Karen's role was to coordinate all the installation with the field. So there was a huge task. There was over 460 mobile installation that had to be coordinated with the field supervisors and the contractors. And she did that very well. This was done actually 2 months before expected to be done. So that went very well. She also put a lot of training package together based on our internal, we have what we call an e-knowledge program. So it's all web-based. That became very handy now with the pandemic because the users can go online and review the training in their own time. So it should also help keep track of some of the finance as well. So Matt McLeod, Colin Delaney, and Amber Isimovich were very key telecom technicians that work on the project. They did all the testing, installed all the servers, testing of the equipment, site installation, commissioning, and some of those sites were very challenging. It was in really remote area and sometimes not necessarily the best time of the year. So did a lot of work there. There was also other telecom tech, and I'll mention their names. So James Hopkins, Derek Myatt, Dave Arnold, Roy Whidden, now retired, and Barry Steve, that's also now retired. He did a lot of work as well. And thank you very much on that, everybody. The NSPI team has managed, designed, and deployed the backend infrastructure in the field, including radio servers, dispatch server, dispatch console, repeater system at all radio sites. So the old mobile radio system, so in 2012, a review of the aging mobile radio system confirmed its end of life status. That system installed in the early 1990s was no longer supported. Over the next 3 years, our team researched several technology solutions. During this time, an approval process began through government agencies, internal and external stakeholders. The approval was granted in 2017 to move forward with the redesigned mobile radio infrastructure system. And I mean, the preliminary design, that started in 2012 onward until the project got approved. There's a lot of preliminary engineering required to put the business case together and see where we needed improvement coverage and so on. The new mobile radio system overview. It's a VHF multi-site trunking system with roaming capabilities. What roaming means is basically like everybody's familiar with cell phone today. So you drive around and you talk, and it's the same idea. The radio can roam from site to site without any user intervention. Follow the new DMR Tier 3 standard using TDMA technology. That stands for time division multiple access. So what you do is when you have a frequency pair, the VHF, this over 12.5 kilohertz bandwidth, that technology allow you to split the time slot in 2 time slot, which give you double the capacity, either voice or data. Include 52 VHF sites covering around 95% of the province for mobile coverage. And it's for mobile coverage, not portable. Mobile is installed in the vehicle, so it's higher power. And I actually think it was a little better than that because we have tools that do live coverage monitoring. And it was better in some area. I didn't expect it coverage, and there's actually coverage. So that was a good surprise. There's some little area that need to be tweaked, but overall it was really good. It includes 2 repeater per site, providing 4 voice or data channels. So there's one of the time slot is dedicated to the control channel. And this is what monitors registration when the radios user drive around or change talk group. And I'll go a little more in detail on that. But when they do that, the controller knows where they are, which site they're associated with, and which talk group they're associated with. So keep track of that. And the other 3 time slot, because we have 2 repeaters, it's either for voice or data. It's a lot of capacity there. It includes redundant site controllers at our main site, Ragged Lake Control Center, and the backup control center in case of failure. So there's multiple dispatch station, again at the control center operators, the backup control center, the RMC, which stands for Resource Management Center. They're the one who issue all the work orders. They're always in touch with the PLTs in the field. Some of our field office and more meaning supervisors, anybody that needs to talk to someone in the field over radio, they can use that dispatch. It's a light application that runs on your PC. I'll show some example later. This digital trunk mobile radio system include voice and GPS location data. It's capable of more, but that's what we're using it for. We have 460 mobile radio installed on fleet vehicle along with 180 portables. The radio system today has 63 talk groups divided by work area. So this is kind of a snapshot of the province with a 52 site overlay on it. Half of those sites are ours and the other half are third party, some share with the government and so on. And this is a coverage map. It's a small scale out version. The white area, which there's not much, which is true, it's a little bigger than that when you zoom in, but I can't do it on a slide. You need a GIS software to zoom in and see it. So that's part of our tool that we use. So the coverage is for mobile only on this map and cover, like I said, 95%. The red area showed the coverage and the white shows the no coverage. And this one's very interesting. It's a live coverage map. So basically it has when the users drive around with their vehicle, they send GPS information. With that GPS information, we receive a receiver, an RSSI, which stands for receives signal strength indicators. So with each of them, their timestamp and all that, it built a coverage map, and you can actually verify your prediction with the live coverage. So if you look at this map here, the green area is very strong coverage, and the yellow is also fairly strong. And then you get into the lighter, when you get in the purple and red, it's a little more weak coverage. And sometime when you see red, you have to look at it every couple of weeks to take a peek. A lot of time, this tool allow me to find a vehicle with bad antenna. If I see in a good area and there's one vehicle that's registering with like a lot of red and purple, then I'll take a look deeper, and then I actually cut a lot of mobile radio with broken antenna since the beginning. We started installing 2017, so that's actually a good tool. That tool also have a lot of statistic that we can do about like repeater loading. I mean, it's endless the amount of report you can do. So you can actually see the status on your system and how well it's performing. You have a lot of busy call and so on. So our vendor selected Motorola solution with Bell as a provider for the new mobile radio system. So it was a Motorola CapMax system. That's how they call it, that meet the new DMR Tier 3 standard. That's a worldwide standard that's for mobile radio, that all the manufacturer has to, if they meet that standard, they have a base criteria that other vendor equipment can work on that same standard. So there's an interoperability between them. Bell provide mobile vehicle installation and base station install at all locations across the province. NSPI mobile radio team was responsible for the VHF design of infrastructure, including the RF design, networking implementation, dispatch servers and console, radio server configuration, site repeater installation, commissioning. So some of the new end user equipment features include text messaging. That's a feature that we disable because it's too distracting for someone driving. We really don't want them to take their eye off, not looking at the road when they're driving. So that feature was never enabled. Integrated GPS encryption. So all the voice communication encrypted over the air on the VHF. So you can't just eavesdrop with a scanner. You would have to crack the encryption key to get in. There's some telemetry, which we haven't really used it for yet, but it's capable of low data rate. Roaming, which I kind of talked a little bit earlier. Software upgradable over Wi-Fi. This is a really powerful feature. So we can do code plug reprogramming over the air. So a code plug is basically adding talk group, changing, adding site, and we can push that over the VHF network over the air. But we cannot do a firmware upgrade because a firmware upgrade is usually like a 20 megabit of a file that you have to download. And we're limited at 4.8 kilobits per time slot. So you would never be able to do it over the air. It's not enough bandwidth on the system. So by being able to do it over Wi-Fi, so when the vehicle come close to an office location and we have outdoor Wi-Fi, like coverage there, we can actually push it over Wi-Fi. That allows us to not have to go to a truck and actually plug yourself in the radio to actually do a firmware upgrade. So we haven't deployed it in the field yet, but that's definitely coming. There's a lot of hurdle working with our IT over security and so on. So, but I think we're going to get there. Let's say if you can hit 80% of your fleet over Wi-Fi to do the firmware, that's only 20% of vehicle that you have to send a technician to do the firmware. So it's a lot of time saving. So future end user equipment. Actually, let's go back for a sec. I forgot something. This is one of the portable we selected here on the right side. It's a full color display. And those radio are waterproof. You can submerge them underwater. They're IP68 rated. You can even drop it from a bucket, which I tend not to challenge our PLT to do that, but they go to those type of testing at the factory. Very, very solid equipment. And here is one of our vehicle, and on the top you can see an antenna here, and then you have someone talking on a mic there. Okay. And what's installed in the vehicle is one of those mobile here, color display as well. They can be bright at night, but there's a dim function on it, so they can have night mode versus day mode. And then this little device here is a high power Bluetooth that actually pairs with the microphone inside the vehicle to allow you up to 200-300 feet away from the vehicle line of sight. So this was very handy for a PLT when they're in the bucket truck up the pole they're working. So those radio is a NN's vocoder, very clear voice. They use AMB+2 vocoders. That's well known and well established in the mobile radio world. Again, talking about clear voice, going from an analog system to a digital system. What it allows you to do in the old world, a digital system, when you get close to a coverage area, get weak at the end, all you hear is noise. With a digital system, with the error correction and all that, you have more talk time, because when you get closer to the end of the coverage area, you can still talk. And what's going to happen is it was just going to drop the audio when you have no coverage. So it allows you a better coverage in one way. It's for the user, it's a better coverage. We have a lot of third-party integration that's working in the background. One of the tools I show you is the live coverage map. That's a third-party integration. I'm going to show a couple more. Registration, deregistration. So you can see when a radio register, deregister. There's different type of call. There's group call, which is talk group based. So if you have everybody registered to a talk group, you can actually hear and participate in that conversation. Which is great for crew when they do switching or they want to calibrate. They have like 3 or 4 different crew working together. They could use that feature. Private call, again, that's one-to-one. So it could be, right now the private call, we only allow it from dispatch to the user and not the other way around. So they can initiate a private call, but because we want to force them to use the group call. Telephone call, feature available. We're not using it because today everybody has cell phone. So if you want to talk on the phone, the cell phone is a better application for that. Over mobile radio, half duplex is a little cumbersome. So we decided not to use it. All call is mean you could actually send a call to all the talk group across the province or target just an area. So this is a feature you could use in emergency situation. This on the right corner here, this is an example when I'm saying a repeater. This is the repeater at the site. There's two of them. And below it, actually, believe it or not, this is our mobile radio server. In the old days, it was two full 19 racks of equipment for the whole mobile radio. So now it's like 3 rack unit, and that's a server. And then there's a redundant one like that at the other location. GPS polling, short data polling, text messaging, all available. Emergency button, very important feature. So if one of our worker get in trouble, he can actually press orange button on his radio or on his mic, and you'll be able to. That emergency goes to our energy control center operators. That right away they respond to the call, and they will either initiate a 911 protocol or whatever it's needed. There's a lone worker emergency. So for someone that work alone in a remote location, like a one person going in a very remote location, and we have a lot of those sites across the province. They have a timer they can set for different interval. So they will tell the operator, whoever's looking after them, I want to set a 5-minute timer. So when you get close to the 5-minute timer, it will send a reminder to the user. His radio, well, this portable is going to go, it's going to make a noise. And all he has to do is press the push to talk button, and that's it. And then the operator knows it's fine. The operator doesn't have to do anything until if the user does not respond to that request, then it will generate a lone worker emergency, and then the operator will try to get a hold of the person. You could have, because a lot of them goes on 4-wheelers and off-road vehicle, so it could be a potential hazard there. There's a man down alarm on the portable. We haven't used the feature, but it's there in case if you fall out, pass out, and you have a portable. But most of our users have mobile, so that's why we haven't really deployed that one. But if you would be in a plant environment, indoor, you could use that feature for sure. So some of the other features, so the caller ID, you can see who's talking. You'll see his ID. There's a late entry. So if let's say if you just power up your radio, you get in your vehicle and there's already a conversation going on in that talk group, you will automatically be part of that conversation as soon as your radio is registered. Stun revive. The stun is a really good function because sometimes you do lose or some radio could get stolen. We can disable them and those radio will never work on our system. So there's a call alert. Basically, from a dispatch point of view, you can send a tone to the radio. It's almost like a phone call. So if the person's not in his vehicle, but his vehicle is on, you can send a call alert, and when the person's come back, you can actually answer the call. So this is just a low scaled down version of a radio management software. And what I was trying to show you here is you can keep track of all the serial number, all the radio ID, when was the last modified. So when you make change, you have to write to them so they can understand that change. So let's say you make a change to a repeater site, you're gonna have to actually let the radio know that the frequency has changed at that site. And it's also a management for all the code plug. They're all centralized. Great because they avoid a lot of mistake in the field. In the old days, you had to keep track of it in spreadsheet and nobody knew which version. This knows what version is installed. Like for example, here portable GIS damage assessment regular, right? And then you have portable telecom and so on. It goes like that. And then there's the mobile as well. So each group have a slightly different configuration in it, depending on their needs. So this is a really important tool for us to manage the system. This is another third-party integration. This one gives you the live traffic going on the radio net. So anything going on, like any user reporting either a GPS or a registration, if there's interference on your system, if a repeater goes offline, you can Like it's very granular. You could go down to the repeater and the repeater 1 or 2 on the site, and you know you could have a problem with a site here or there. So there's always a sanity check on the repeater view. And when you do like a over-the-air update, you can actually follow it here. You can actually see the radio from start to finish. It receives a code plug update. So it's actually really neat. Okay, so this one is the dispatch console that I was talking about earlier. This is a live screen. I just took a little snapshot, and that's me here doing a test. So when it's green like that, I mean I'm talking. And when it turned blue, the other person is talking back to you, right? So it's push to talk, so you have to press and hold a button, and when you release it, um, it's how two-way radio work. And then it record all the voice conversation, all conversation between field users and our control center operator are recorded. It's a mandate. It has to be for safety, and they get audited on it as well. So here you could see a bunch of PTT buttons. Those are all different talk group. And then on the left side, you could see operators and users that are logged in. And then you can also see the radio here. These one are green, mean they're actually tracking GPS. So they're online plus tracking GPS. Okay. And this package is very easy to deploy on any corporate computers across. And you can be home over VPN and talking to someone in the field, no problem. There's another snapshot here, kind of show you a map with some radio user. Gray mean they're offline. That was the last location they register. We have site in there. So you can see if a guy enter a substation, operator kind of really like that because someone's calling for checking in, checking out of a substation. They actually can see the guy there. If he forgot to call back, you can actually see the guy is leaving the substation. So it's actually a really neat feature. So infrastructure here, the system is housed on NSPI owned private telecom infrastructure and is designed with a high rate of reliability and availability. Each site architecture was designed with its own battery backup as well as generators that are maintained by NSPI technicians so that it is not reliant upon third-party service during mission critical event. And this is just a random site, what it looked like. And on the right side here is a tower. Those towers vary in height. They could be anywhere between 100 feet to 340 feet. Some of the tallest one are 340. So they're big towers all around the province. Yeah. You probably see them if you pay attention. You'll see them. You'll see some of the cell towers and so on. This typical gear that we have in our site, oh, this one's a small site. Um, so there will be like a battery bank here, and then there'll be an equipment rack. And then on the right side here, those are filters, bandpass filters. We call them multi-coupler. Allow us to connect multiple repeaters to one single antenna. And this is another installation too. So basically one of those filter and one of those filters for your transmit and receive frequency. So they're big. They're quite big because it's VHF. They get smaller if you go in higher frequency. And then the repeaters mounted under them. On the right side here is one of our courageous riggers that would climb those 300 feet tower. This one, I'm not sure which one that one is, but it's high. So they go at the top. This is a mass pipe, and the antenna is actually mounted right at the top right here. You can see the element here. The antenna, believe it or not, is 20 feet tall. So it's hard to see the scale from the ground. And whoever took that picture, I believe, was one of our tower consultants that go and inspect the tower after the installation. So he would have took he climbed the tower as well. So, so engineering and design. So I'm going to try to go over to see some of the major tasks of engineering that was required for this kind of project. So each RF link budget must be analyzed with respect to antenna gain, cable loss, and RSSI to ensure reliable operation during extreme weather condition, rain, snow, and ice. The operating frequencies must be selected to ensure reliable interference-free operation and not to interfere with other user in cooperation with Innovation, Science, Economic Development Canada. They're called ICED, formerly called Industry Canada. It's they changed that a couple of years ago. So they're the Government of Canada Spectrum Management Operation branch and the microwave frequency database. They're the one who manage the entire RF spectrum across the country. They're equivalent of the FCC in the US, and you are not allowed to put any equipment, radiating equipment, in a license bin without their authorization and approval. Studies will require and performed by the lead engineer in order to alleviate any public perception of misinformation that might exist regarding the system RF frequencies having the potential to cause cancer and other health issues. So this is something that came up midway through the project. Some of the users were concerned about the antenna being close. Most of the antenna on the roof, but some had to be mounted on a fender. It was a little closer to the driver. So we did a safety report based on Health Canada Safety Code 6 was issued, and we had to present that to the users across the province. And yeah, it passed. There was no issue there. It passed the Health Safety Code 6. We had to use specialized equipment to do the testing. We did that ourselves, and that was good. After we did that, everybody was happy. They felt that it was good. No different than people using cell phone all day, right? Some people have concern over that, so you have to alleviate that concern. The site were selected using computerized software to simulate different radio frequency, behavior range, interference by itself and others. One site selection was made. Application has to be submitted to ICED, and ICED is a frequency approval agency and monitors frequency spectrum and provide final approval. A couple of times throughout the project, they approve a frequency, and then we start turning the repeater on. They come back and they said, we got a call from New Brunswick X users, and they're getting interference. So we got to change the frequency. So you're going to get a few of those during a big project at that scale. When I say this scale, I'm talking about 52 site, 104 frequencies. That's a lot. So radio propagation, including selection of new site to improve limited coverage obtained from previous system. That's one thing we want to improve the coverage from the old system. During the life of this project, just before that project, we had a backbone upgrade, which part of it was to also, we had to build new infrastructure. So there was 5 new radio sites were built from ground up, including telecom shelters, towers, which involved working with our land acquisition specialists and to assist with negotiating with third parties. We had to reuse and reorganize the existing VHF frequency. We had about 20 pairs. So we went from 20 pairs to 104. And so at VHF, if you're lucky, you could reuse that frequency 5-6 times in Nova Scotia max, based on the terrain and all that. And if you're not lucky, 2, maybe 3 times. So that was quite a challenge to be able to do that. The radio interference and intermodulation analysis to avoid issue with our own system. So that had to be done up front. We also have a lot of site co-location with third party, and we had to make sure that when we install equipment on their facility, we didn't cause that problem with their equipment. Frequency application, what I said, working with their spectrum official to ensure new frequency would not cause any issue with other license operators. So first you have to clear it with yourself, and then you have to go to them and say, okay, would I work with the rest of North America? So it's a process. Usually, if we're lucky, you get in 2 or 3 weeks. If you have to go to the US for approval, which we had quite a few of those, and they had a government shutdown in 2019, I think, or 2018, one of those years in January, and everything slowed down there. So we have, if you take Nova Scotia and you cut a line through, like probably Bridgewater down to Bridgetown, anything past that, closer to Yarmouth, has to go to FCC for approval. So yeah, that took a while. We had to get temporarily approval letter from Industry Canada, so they allow us. But with the exception that if it come back from the US, we have to change it. So we took the risk and it worked out actually quite good. Work with third-party operators to co-locate. Again, I think I went over that. The new equipment use a RF filter to co-locate with the same antenna system. Make sure NSPI equipment does not cause any interference with their equipment. So work with the radio equipment manufacturers to test 4-site staging at a location. So that was an agreement when we purchased the system. Motorola insisted that they test a few sites. It's okay, well, you can test 4 sites to make sure their server was configured properly, which is good for us too. And then we had to make some configuration change in the server, but we don't have access to it. The deep down of the server, we can't, it's proprietary and only Motorola is allowed to do it. So we had to flew 2 of their engineers to come meet with us. We set up a lab, spent a couple of days, made all the IP change, all the configuration change that need to be made, and we were done. So that was good actually. And part of that, when we had that set up, we also do a lot, we did a need analysis. We brought a bunch of key users across the province to show them the system, to show them the dispatch, and make sure that it will actually meet their needs. And so that was a really good time when we did that. We did that over a period of 2 or 3 weeks in 2017. So that was a very good proof of concept as well. Okay, so a review of each site, power load to ensure that new equipment doesn't affect NSPI, 8-hour battery backup time. That's our standard in most areas, it's 8 hours. Upgrade to the existing charger and larger battery bank as required for each site. So of course we're putting additional equipment, so we had to make sure that we're still meeting our 8-hour backup time. A battery is our first line of defense, because if the generator doesn't start, the batteries, you're relying on your batteries. So that's super important for us because as we know, mechanical devices do fail during storm, and you're always going to have 1 or 2 generator issue, either not starting for whatever reason. So the battery bank is our line of defense that way. We had to develop a bill of material for all equipment required to install the new equipment at each site. Develop a testing and configuration procedure for the telecom tech to use to configure the equipment to be installed at the radio site. And that included also not just that, but when we take a mobile out of the box and we need to get it installed somewhere, there's a procedure we put together for the technician to follow. So consistency, make sure that they have everything, the mobile are marked properly, there's all the label on it, it's in each database and so on and so on, and it works before we send it out to the installer for installation. Issue drawing package, we call it requests, RFWs, requests for work, that include installation drawing, rack layout, termination drawing, telecom circuit design, cable lists, removal, instruction for the old mobile radio equipment. We had to work in conjunction with the external consulting structural engineer to ensure that each tower was adequately designed to support the new antenna system. So we installed newer VHF antenna as well. The other one was super old. Some were like 20 years old, so it needed to be refreshed. So yeah, we installed new gear, new feed line, everything. All site coordination with tower, we did all the site coordination with tower rigging company for the old antenna feed line removal and replacement with the new antenna system. We developed commissioning procedure and final acceptance. This is actually the engineering IP network design. So design of mobile radio server and client dispatch, console network architecture. Prepare the telecom IP MPLS network to be ready for the new mobile radio system. If you don't know, IP MPLS is set for Internet Protocol, multi-protocol label switching. It's something that that's been used today. It's the new technology for IP that's allow you a more secure, more reliable communication, more granular, like we need it in the utility. So Develop a new IP plan for the new mobile radio network. Work with the radio equipment manufacturer to do foresight staging at our location. Part of this task was reconfigure the radio server to work with the new IP plan. A manufacturer had their own thing, and that didn't fit our internal IP configuration. One thing I probably forgot to do here, work with our IT folk on the firewall. There was a lot of firewall design in the background as well that interface with our stuff as well. Include initial server setup would be reconfiguring to work on NSPI telecom network, radio site work scoping before issuing the request for work, issue RFW for new mobile radio and dispatch server at our main control center and redundant at our backup control center, and also provision the IP MPLS router for the new mobile radio service. So a new mobile radio system is 100% IP based. There's no legacy TDM, time division multiplexing technology there. It's totally IP based. Some of the benefits. Utilize the existing backbone infrastructure to connect to the repeaters to each other with the controllers and dispatch console. The trunk system provides seamless province-wide radio coverage from one end of the province, even in the event of natural disaster. So a user could be, so because it's talk group based, a user would be registered to, let's say, PLT Halifax. He could drive to Sydney, and the other guy could be in Yarmouth, and the rest of them in Halifax, and they can all talk, like on one talk group. So it doesn't matter where you are in the province, it does it automatically. It knows where the user are registered to and associated with each talk group. So that's very powerful that way. Provide significant safety and national security benefit. Most NSPI vehicles are radio equipped in addition to the portable radio carried by internal field personnel and contractors. Communication is possible between control center operators and PLTs, power line technician, using voice while even in a bucket truck working on a power line. Used extensively by hydro operational personnel where other form of communication are not available in order to perform their work safely. So a lot of our hydro plant are in super remote area, in low area, like super low area. There's nothing else there. There's no cell coverage. There's nothing. One example, I didn't put it there, but we have a hydro, a RECO hydro generating station. This is between two mountains up in the Cabot Trail. And it's an underground powerhouse with a tunnel about 1,500 feet long, 1,800 feet, sorry, before you get to the powerhouse, which is there's big area in there. They never had coverage in there, so we install repeaters inside the powerhouse with antenna system that allow coverage everywhere inside the tunnel, in the powerhouse, and even outside closer to the admit building. The coverage was a little weak, so we increased the coverage there. And they have coverage in the back lake, which people don't realize. The back lake are up in the island. Some are like close to 45-minute drive. In the winter, the only access is Skidoo. So they're super remote site. Very important for safety. So it was designed for rugged operation by self-healing feature and dispatch redundancy with primary and other lake location backup facilities. Other features make the radio system virtually indestructible. I wouldn't bet on that. It's just it's super, super reliable. We haven't had any, knock on wood, we haven't had any failure since it was put in. The user equipment super reliable. I think we had maybe 2 mobile radio return in 3 years, and we're not even sure if they were not working. We just swapped them just in case there was an issue with the radio. And I think we sent 2 for repair, Motorola. So that kind of gave you the sense of how good the equipment is. Operator, user safety, any mobile radio system failure during a storm event could have a negative impact on restoration time. Lack of communication causes inefficiency in work completion. Employees are required to drive into a cell phone coverage area in order to communicate with control center operators, placing NSPI personnel at risk in potential dangerous environment. The emergency NSPI mobile radio dispatch system remove any previous safety concern allowing effective and immediate communication in every area of the province. And again, if there's an area that's bad, we can expand the system, the coverage for those areas. It's a big deal. And what people don't realize is when the PLT work on lines, they're always in constant communication. When they're ready to bring customer back online, they need a confirmation from the operators. So that communication is super important that it's there during, especially during storm. And that's my last two slides. So this one was Hurricane Dorian, testing the system. As weather events such as hurricane, ice, and snowstorm become more prevalent, emergency communication are imperative and invaluable to NSPI customers across the entire province. When Nova Scotian thinks of Nova Scotia Power, they typically imagine that the utility is simply responsible for power without considering the infrastructure behind their source of electricity and the cause and effect that the weather event can have that may result in the loss of essential services. In September 2019, Hurricane Dorian proved to be a force to be reckoned with as the hurricane force winds and torrential rain pounded the province, toppling trees, power, phone line, and its spat. The emergency NSPI mobile radio dispatch system proved to be invaluable during the storm, with phone communication and cell tower rendered ineffective. So for people that live in Halifax, I felt Halifax didn't get hit as hard, but everywhere in Nova Scotia was disaster. So, and it's rural. So in its final testing phase during what would prove to be one of the most damaging storm in history for NSPI infrastructure, the opportunity to test the emergency NSPI mobile radio system broad range of capability presented itself during Hurricane Dorian. So at the highest rate of outage across the province, there were 400,000 plus customer without outage, 480% of NSPI customer without power. The effectiveness of the emergency NSPI mobile radio dispatch system allowed NSPI crews and emergency dispatch to communicate through select radio frequency that are completely separate from daily phone and cell communication, allowing NSPI to restore the majority, 85% of affected customer in record time of 4 days. So most cell network are only designed max 8 hours backup time. They don't have generators across the province. So when you have extended outage that pass a day, most of those systems, if the power is cut off to those systems, it's gone. You're done. So that's why it's important to have a system that's designed to withstand that type of storm. And we look after the infrastructure. So if there is one site that goes down within a few hours, it's back up. Like it get priority to be restored. So crews dealt with fallen trees, which took down power line and broken pole. Many of the repair were complex. Damage include an estimated 7,000 instances of the line broken by trees, and with trees leaning on them, 375 broken or leaning pole. So Nova Scotia Power at the peak had 368 power line crews, and I'm not totally accurate on the number, but we have about 160 regular PLTs. So that's almost more than double and a half what we normally have. That's how many crew that had to be brought in to help restore power during that storm. So 81 forestry crews, 67 damage assessment team dedicated to restoration effort during weather events. Whenever necessary, crews are brought in from New Brunswick, Newfoundland, Labrador, Ontario, Quebec, Maine, Florida, and I'm sure during that storm, yeah, it could have been other areas as well. The emergency NSPI mobile dispatch system is made available to any team needed for effective and expedient service restoration. So we have a lot of portables. So when we bring crew out of town, they work in group. So one of the main lead crew has a portable, and they can communicate because the portable can do simplex. It's radio to radio. So they can talk to each other. And when it's time to restore, one of our PLT will actually get a hold of the control center and get the feeder restore. So the emergency NSPI mobile radio dispatch system proved to be a huge success during this natural disaster and was officially brought online November 2019. The only reason it wasn't online before like officially, is because we still had an operator that needed training, and that take a period of a couple of months to do that, just because they're on the rotation and it's hard to get them for training. So this was the presentation. If there's any question, I would be very happy to answer them. There's a chat window there, and I will wait a few minutes and see what. Oh, there's one typing there. So the question was, can external PLT crews use the system? Yes, they can if we give them one of their portable when they come in, but we haven't done it that way. I think the kind of the protocol there is there's always one NSPI representative with the out-of-town crews to report when things are back online. So it's a very good question, by the way. Okay, so here's another question here. What are the carrier frequency used? The minimum RSSI required for user radio and the typical data bit rate throughput of this model. That's a good question. I like that. Okay, so we'll get a little more technical here. So the modulation we use, so we use VHF frequency, the 150 to 170 megahertz range. So that's our area, the band that we're in. The bandwidth is 12.5 kilohertz. And that's narrow band. That's what we have now. And the frequency used, the carrier, so I told that. And we use 4 FSK modulation. It's FSK stands for frequency shift keying. And the minimum RSSI required for user radio. Okay, so that's it's a good question, very good question. So when you do a coverage map, you have to simulate a radio in the field. So the repeater are sensitive from the manufacturer up to neg 120 dBm for a 5% bit error rate. That's enough to be able to have a voice quality that you can understand before it get all distorted. That's from the manufacturer. In the real life is, depending on the site you're in, there's a lot of noise. So there could be a site noise just in the band, and you can't get rid of that because it's just there's so many frequency around. So you would get, like around neg 115 dBm of receiver sensitivity at that point on a radio. And your system has to be balanced. So your repeater ERP, effective radiated power, has to be equal to your transmit power from your mobile. So we're licensed for 25 watt of VHF. And the mobile are 25 watt ERP as well. So that's a balanced system. The portable are not balanced because there's less transmit power. That's why you get less coverage with a portable. Well, there's other factors, the height and so on. So let's move on because I could go all day with that stuff. The data bit rate per time slot is 4.8 kilobits per second. So it's very small, but it's enough to do a lot of over-the-air code plug changes, something like that. Okay, has there been any failure of individual units since it went so? Yeah, so I like I said earlier, I think we had 2 or 3 units that we had to return to Motorola. That's it in 3 years. So that's actually a really good sign that the equipment is rugged. And there's another question here. From start to finish, how long was the phase out of the old system and the full capability of the new system? So the old system was so obsolete, and it was so we were lucky that way. Let's call it this way. The old system was not used as much. It was in bad shape. Remember, it was done in the 1990, and the equipment manufacturer discontinued the equipment in early 2003, maybe 2005. So we could not get any more user equipment. So there was very limited people that had it. So what we did, we just cut it off. We just shut it off at some point. We say, okay, we're going. You no longer have it. The old system you can't use, and we start deploying. It took a 2-year deployment to do the new system. Not everybody has that chance to do that. Some utilities, their system are newer, and you're moving to a newer one. That's very complicated because you have to do it in phase and area. We did in phase, but we didn't have to worry about the old system interfering with the new system and mix max users. So we were lucky that way. Okay, during the transition period, were crews carrying 2 radios? So no, not really, because like I just said, we cut over and we just said, okay, we left it on as far as we could. We set up all the backend infrastructure, and then we start getting going. We said, okay, now, and I think the switch died, or the main switch just died midway through the project. So that gave us like an incentive to, okay, guys, we're done. You have to wait for the new one. Okay, so another question. Can you provide a brief explanation of the coverage design process and any challenge phase? Okay, um, I will answer that one. Let's see what, try to answer the easy one first. And I'll come back to that one. What is the backup plan if the mobile radio frequency is too low between the users who are communicating from different cities like Halifax to Sydney? If it's too low, I'm not sure you mean by frequency too low between the users. Oh, you mean the usage. You're talking about usage, correct? Frequency usage? Okay, cool. So yeah, of course, there's some area in the province that use the radio more. You'll notice that in urban area, they don't use it as much. It's just because there's enough communication with the cell network and everybody get used so much to cell phone now that the need is not there, but they do use it between them. And what I found out too, some of the users don't always connect to the network. They use it simplex, truck to truck. So there's other way they use it as well. But you're talking about traffic. So we haven't had a traffic. So during the peak of the storm, I was monitoring the network, and we had an average of 4 calls per minute across the province. So that's the highest rate we ever used it. On a normal day, it's going to be a call every few minutes. That's all you're going to see really. It's when the guy go in bad area and they need to talk to the operator or need to talk to the crew, they'll use the radio. But when we go in storm mode, that's where they use the radio the most. Okay. Is there a smart power meter system connected for some? No, there isn't. So we haven't connected the smart meter to our radio system, not today. Like you said, there's a bit of a limitation, 4.8 kilobits per time slot, and we have 3 usable time slot per site. So that's not a lot of bandwidth, and we're rather keeping it as a radio system. So I'll go back to the other question here. It was a good question. Can you provide a brief explanation of the coverage design process and any challenge faced? Well, the challenge is it's the terrain, right? The terrain has always been the challenge. So the one of the main challenges when you look at improving coverage in an area is to decide where you're going to put a new site. Well, first you want to find out if there's existing tower that you could use or existing site that you could co-share with someone. That's the first process. And Industry Canada, I said, kind of force you to do that first, right? The process after that, if that doesn't pan out or it's not the place where you need it, you need to start looking at how, because we need IP capacity. We need all those sites are connected via IP as on the backbone side. So the radio itself, repeater has to talk back to the main controller, which is at our control center. They're constantly talking. So you need that communication path. So when you decide to add a site, you're going to actually look at, we use mostly microwave point to point. We have our own utility band license in the 7 gig high capacity, and we're extending that. So we look at a site that makes sense. You have to look at the cost, the location. Can you get land? Can you do some sort of deal? So that was some of the challenge. Some of the site we co-share with the government because they needed a site. We needed a site. We said, well, we'll give us the land. We'll give you the space on the building and our towers. So that actually we did that in 3 locations, and we did another with a different government agency. We did in 2 sites. So that worked out really good because we didn't have to go to private landowner to do that. So when you do simulation, you're looking at the area, you're looking at elevation. Of course, for best coverage, usually you need higher elevation, but you also have to be able to link it somewhere to our existing network. So that takes a lot of time to move stuff around, and then you have to work also, like I said earlier, with your land acquisition people, because you might want it here, but it's not feasible. You can't get the land. So I hope I answered enough that question. I could go more, but there's more question. What area was more challenging to design when it comes to terrain? Annapolis Valley or Cape Breton? Oh my gosh, that's an easy one. Cape Breton. Cape Breton is definitely harder when you get into the island. It's very difficult because it's all ridge and mountain. And I don't know if people realize that people live in the ridge. They live along rivers. They live like that's just human nature. So you have to kind of maximize coverage in those areas, and that's not a simple task. Sometimes you have to go high, but sometimes too high is no good neither. So you want a site that's a little lower, but target more the low area where you want to get. So there's a bit of one more here. One last question. Yeah, sure. What is the main technology used for backhaul? Fiber, microwave, and satellite. So we have both. We have fiber backbone for some of the core. But most radio site, because they're remote location, it's all over microwave. We do not use satellite. Satellite's not a reliable way of doing it. We use point-to-point microwave system in the license band, and it's high capacity. So we can go up to 30 megahertz channels and hundreds of megabits, 300 megabits of bandwidth, and then you can actually the technology allow you to stack radio, so you can keep increasing. You just add more radios on the same antenna, and you can double your bandwidth. So yeah. Oh, there's another question. I like question. That's great. So it's very interesting field to work in. That's something you're never bored. You're always learning something new. Um, like some of the one of the thing I need to mention that we ran into um, a weird interference issue in one of our site, and but all the tests set there. We did like with directional antenna, tried to find what it was, and it happened to be it was generated from our fence around the site, and we tried grounding the fence, and it just we couldn't get rid of it. It was a lot of there was 3 broadcast towers around our site, and it must have been just the right place, the right location. Anything metallic could become an antenna, right? And it was radiating noise, and it was quite strong. It was like neg 90, which is quite strong, like when in the radio world. So we had to change the frequency there, unfortunately. But it was very interesting. That was an exciting one. So I think that unless there's more question, oh, there's one more. Okay, no, so people say thank you, and I think that's the presentation. If you have any more question, feel free to send me an email or something like that. This presentation is going to be, I think it's recorded and it'll be posted on Engineer Nova Scotia if some people want to go over it after the fact. So that's great. You're welcome all. Thank you for your time as well. Very appreciated. Have a good day all. Bye-bye.